Hey guys, welcome back. Today we are not going to do too much that's new other than add bounds to the integrals so you don't have the plus c at the end. And I'm going to introduce how to integrate tangent. But on the whole, it's kind of the same thing we did yesterday, but a little bit more practice. So for starters, on your own paper, or at least in your head, I would like you to hit pause and do these three problems just to keep yourself fresh. And these are not U sub. You can use U sub for these, but you don't have to. Hopefully you know why. Why do you not need U sub for any of these? Because the derivative of the inside is a number, and so you can just divide by the derivative of the inside. If the derivative of the inside still has an x, that's when you need U sub. So hit pause and do these integrals real quick. Okay, remember the integral of sine is cosine, or negative cosine, and divide by the derivative of the inside. That's where that 5 came from. For the e, this is just 3e to the negative 7x divided by negative 7. And this one is natural log. You may have forgotten that one. So this is the natural log of 2x minus 7 divided by 2. Okay? So study those if you didn't know how to do any of them off the top of your head. All right, on to today's lesson. Oh, actually not. This is another one that you should already know how to do based on yesterday's lesson. So hit pause again and do this one. Okay, so your u is something you can do the derivative of, and you have to have both the u and the du in the problem. I have to be able to see all of this and all of this in the problem. So I can see the u right there, but I also need to have a 6x dx. And you can see that what I'm missing is the 6. So I'm going to throw a 6 right here and balance it out with a 1/6 out front. Now rewrite everything in terms of u's and du's. The 1/6 comes down, the integral comes down. The 6x and the dx combined, 6x and dx get replaced with du. And here I have the square root of u. So now it's just a normal integral power rule, u is to the 1/2 power. Okay, so this tells me I still have to integrate. So I bring down my 1/6. This is u to the 1/2. I'm going to add 1 to that, which gives me u to the 3/2, and divide by 3/2, which is the same as multiplying by 2/3. Simplifying just that, the 2 and the 6 can cancel, and I get 1/9 u to the 3/2 plus c. Change u back into what it was. Okay, that's just a review from yesterday. Okay, now, what do you do when there are bounds? Well, you could treat this the same exact way and do just what we did on the last problem, and then at the end plug in a 1 and a 0. But they get you on the AP exam because sometimes they don't ask you to solve it, they just ask you to set it up. Okay, so here's what I'm getting at. Let's go ahead and write down what our u and du are. Okay, remember u has to be something I can do the derivative of. So this is the bigger bunch of junk, and the derivative of it is this. So I'm going to let u be the denominator. Du would then be, derivative of 1 is 0, so it'd be 1 plus e to the x. Okay, dx. Now I'm going to rewrite this in terms of my u's and du's. Well, the denominator is u. All of this is du, but I'm going to put it out here. That's a little easier for me to look at. Okay, and now here's the little glitch when you're doing u substitution with bounds. I technically cannot put the 0 and 1 here. Okay, that would actually be wrong, and on a multiple choice test, if you did that, that's where you would think it was right and it's wrong. Okay, this is technically incorrect. Here's why. Think about it. These are x bounds. We're supposed to plug them in for x. So if you put them in the problem with u's, it's technically wrong. Now, if you leave them there and you remember to change them back into x before plugging in the 1 and 0 and subtract, you will get the same answer, but sometimes they don't ask you to solve the problem. They just say set it up. So this is technically wrong. What we want to do is change those into u bounds. So to change them into u bounds, just remember that these are x's, and we want them to be u's. So you're going to go to the u and plug them in for your x. So let's plug in this 0 right here. If x is 0, then this is 0 and this is 0. And u would then equal 1 plus 0 plus what is e to the 0? Also 1. Okay, so that would equal a 2. So when you plug in that x is 0, you get that u is 2. And now you got to remember that you're plugging this in for u, not for x. Okay? Now let's plug in the 1 for x. If x were 1, we'd get a 1 here and a 1 here. So that's going to be 2 plus e to the first, which is just 2 plus e. Well, that's very weird, but that's what it is, 2 plus e. Okay? Now you're going to integrate like normal, and you have to remember that what you have now is u bounds. Plug them in as a u. Okay? So integrate like normal, we get the natural log of u, and we're going to plug in u bounds. Okay? So plugging in 2 plus e, we get the natural log of 2 plus e minus the natural log of 2. And that's probably how you would leave it, just like that. Okay? It's possible, you may not remember this, but with natural logs, subtraction can be rewritten as division. So it's also possible that they might write it like this. The natural log of 2 plus e over 2. You may not remember that, but subtraction can be rewritten as division with logarithms. Okay, so either one of these answers would be correct. Okay, so let's reflect back over that problem from the top. You start out like normal with u and du, okay? But because they sometimes try to trick you and ask you just for the setup, you want to remember that these are values of x and these require values of u. Now, having said that, if you, at this point right here, changed u back into the values of x, and then you use the 1 and the 0, you're going to get the same answer. This is actually quicker using u-bounds, and if they don't tell you to solve the whole thing, you'll get this problem right when they just say set it up. But the risk here, the common mistake, I guess, the common mistake is people forget that these are values of u and accidentally go all the way back to x. Okay, so you got to plug u bounds into u or x bounds into x, but not crisscrossing that. To play it safe, you might want to write u equals 2 and u equals 2 plus e in your bounds. That'll save you. Okay, so you remember to plug it in for u and not for x. Okay, one more thing for today. After we integrate tangent right now, you're going to want to memorize it. It is on your reference sheet, and it is on that list of integrals on in the back of your book. Okay, so to integrate tangent, we don't have a rule for integrating tangent. We know the derivative of tangent. The derivative of tangent is secant squared. So we know how to do the derivative of tangent, but using this, the integral of secant squared is tangent. That doesn't help me for this problem, so don't confuse that, okay? To find the integral of tangent, you can actually use u substitution if you rewrite tangent using its definition. So what is the definition of tangent way back when? Sine over cosine. If you rewrite it as sine over cosine, now we can use u substitution. Okay, so if I let u be the denominator, the derivative of that would be negative sine. Okay, well, I don't have a negative sign, I have a positive sign, so I'm going to throw a negative here and balance it out with another negative here. That's still a positive 1. Okay, when I rewrite it, I have a negative out front, my u is on the bottom, and all of this is du. Okay? Now integrate, and we get negative natural log of u. Change u back into what it was, and it's negative natural log of cosine of x plus c. Okay? And that is now something you can memorize and apply as a formula. Okay? Or just remember to always use u sub to figure out the integral of tangent. Personally, I'm bad at memorizing things, and I already remembered that sine over cosine is the same as tangent, so I just use u sub. I honestly don't remember this formula, but if you're good at memorizing, you can do that. All right, so now either apply the formula for this next problem, or redo the same exact process using the definition. Okay, hit pause and give this one a shot. Okay, I'm going to do it the same way I always do these. Like I said, I'm not good at memorizing formulas. So I'm going to use u sub. Let the denominator be my u. du would be negative sine of 3x times 3. Okay? Now we got to see what we have over here. I have the sine of 3x, but do I have the negative 3? No, so I add a negative 3 here and balance it out by dividing by negative 3. Now when I rewrite it, I have out front, I'm going to have a negative 2/3. And now all of this is u, and all of that numerator is my du. And I think that's nice and easy. So we get negative 2/3, the natural log of u, which was the cosine of 3x. Okay? Now compare that to if you use the formula. Notice you still will have to remember, if you use the formula, you still have to remember to divide by the derivative of the inside. Other than that, I think you would have gotten the same exact answer with the formula. Okay, so try to memorize tangent is u sub by rewriting it as sine over cosine, or add it to your list of formulas to memorize. Nothing new really with your assignment today. Good luck, and please remember, guys, you're not alone. If you have a question, message me. Don't skip any problems in your homework. Every single problem, you have to know how to do this cold, okay? These are still basics right now. It's not going to really get any harder, but you need to know all of this. So make sure you go all the way to the end with your homework and ask your questions, ask your questions, ask your questions. Okay? Good luck. Bye.